Okay. So now I'm going to share with you, continue with our class, which is the derivatives. Okay. So please take give your full attention to this class. Okay. And then I will show to you step by step in answering the question regarding the topics, and at the same time, as usual, I will give you also the link to other lecturers or teachers that I thought maybe can help you, okay, to understand more on the topics. Okay, so don't give too much apa benda alasan dalam bahasa Inggeris. So please don't give. Okay, so jangan bagi alasan yang terlalu banyak pada saya. Okay, kalau awak tak berjaya, itu awak punya sikap sendiri, bukannya salah orang lain. Okay, faham tu? Kenapa masuk lambat sangat ni Ayu Nafira dengan Labib? Okay, so today on this topic on derivative 3, we are going to have a look on logarithmic differentiation, rates of change, critical points, maximum and minimum values, and how derivative affect the shape of a graph. All right. So at this time, I mean this point of classes, of our classes, you should understand that derivatives is all about graphs. Okay, function that involves or apa ni involves in graphs, shaping, maximum and minimum values. Okay, nanti kita akan tengok absolute optima, things like that. Okay, critical points, rate of change. This is all derivation about. Okay, if we are going to have a look on integration, that is all on apa benda pula? Luas ataupun apa nama kita panggil tu? Area or isi padu or volume. Okay, that is the integration part. But in differentiation, it's all about the graphs. All right. So at the end of this lecture, students should be able to understand the derivatives and its function, and also student can solve mathematical problems within this topic. Okay. So now differentiate the function. For example, 1, y is equals to x to the power of 5 divided by 1 minus 10x times x squared plus 2 to the power of half. Okay, and then the second one, differentiate the function of y is equals to x to the power of x. Because I record this class and then I'm going to upload it in YouTube, so I think I cannot click on the YouTube to watch, because if I click it and then I upload it in the YouTube, there will be like copyright issue. So if we have time today, we will watch this YouTube together without me recording through Zoom, right? If we don't have time, I will always give you these notes, and then study this note and click whatever link that I gave you, because it is all for your own benefit, not mine. Okay, I'm already a lecturer here. Okay, you guys are students, so you need to study. All right. So now, how are we going to differentiate the function? Okay. So let me open the whiteboard lah, easier for me to write. Okay. So given the function is y is equals to x to the power of 5. This is okay. 1 minus 10x times x squared plus 2. Okay. Okay, so at this moment, you guys, students should understand that this is also equals to half. Okay, so this is easier for you to to play with the numbers. Right? So what are we the easiest way to answer this type of question is by put ln to both sides. So here you add ln, and also this side also you're going to add ln. Divide by 1 minus 10x x squared plus 2 to the power of half, right? And then you are going to have pecahkan this one, and you're going to have ln x5 minus ln 1 minus 10x minus ln x squared plus to the power of half. Okay, from here to here, and this is like we kept just for you. You already know, you should already know how to do this from here to here. Okay, now derive both by using implicit differentiation, student. If you remember, I already taught you this on our first slides. Okay, derivative 1. Okay, how to do the implicit differentiation, because we have here y, here x. So we need to do or to finish this question by using implicit differentiation. So now we have y prime over y. Okay, why? Because the differentiation of y prime for ln is 1 over y, right? So y prime over y, you need to do it y prime because it is implicit differentiation. And then, sorry. Okay, 5x to the power of 4 over x5, right? Because ln x is 1 over x, right? So this is x to the power of 5, so 1 over x over 5. X to the power of 5 is 5x to the power of 4. The differentiation, divide by 10 minus 1 minus 10x. Okay, if you don't remember, this is the example that we have already tried to answer the question on last week class, right? On the notes on derivative 2. Okay, minus half. Okay, x squared plus 2 negative 1/2 2x is inside here over of 1 over x squared plus 2 to the power of half. Okay, don't worry too much on how I differentiate this so fast. Okay, after this class, take a piece of paper and try to differentiate this slowly, okay, by yourself, right? So that you can understand better. Okay, if you do extra work, it's for your own benefit, not for my benefit. Okay, so it's up to you whether to do it or just to ignore my class. 5 over x plus 10, 1 minus 10x minus x over x squared plus 2. Okay, okay. So if anyone wants to take picture on this, just screenshot it, because I want to move on to the next whiteboard. This is already full. Okay, so now y prime, okay, you ambil y yang kat bawah tadi, you took the y, 1 over y tadi, you bring it here, so it will be y 5 over x plus 10 over 1 minus 10x minus x over x squared plus 2. Okay, and this is equals to y ni, you ambil balik yang soalan tadi. Okay, you took back the question, the original question of y, which is equals to x to the power of 5 x minus 10 x x 1 okay, 1 minus 10x x squared plus 2 to the power of 5 times all of this, 5 over x plus 10 Okay, so this is the final answer. So you can differentiate it without any problem. Okay, so do you have any question on this on this example? Okay, because there's no answer, so I hope you understand it. Okay.
Can I ask something?
Siapa tanya tu? Anusha ke?
Yes.
Kenapa Anusha?
Over X 42 or what? What's that?
Saya dengar, kenapa saya dengar awak bergema? Macam mana? Macam mana Anusha?
It means like X over X 42 or what?
Mana 42?
Y prime equals to Y 5 over X plus 10 over 1 over 10X minus X over X 42.
No, this one is X squared plus 2. X squared plus 2. Tadi tu saya tulis tu tak comel. Ha. This is this.
Okay, thank you, Doctor.
Just the typo. It's not typo actually, but my pen, you know, like gabung together. Okay? Alright? So now we are going to have a look on the example 2. Okay, the example 2 is y is equals to x to the power of x. So how to answer this type of question? How to solve this type of question is also by adding ln here and also here. And it will be x ln x. So how to solve this is by using product rule. Okay, so remember product rule, uv prime plus vu prime. Okay, so you take this as your u and this as your v, and you will get also complete it using implicit differentiation because you have y here. Okay, I write it here so that student will understand better. So you get y prime over y is equals to x 1 over x 1 plus ln x 1 is equals to 1 plus ln x. Alright, so y prime is equals to y 1 plus ln x, which is also equals to, ambil balik y tadi, x to the power of x 1 plus ln x. Okay, right, this is easier than before lah. Tapi if you don't know how to solve this type of question, when I give you question in test or in exam, you like terpegun sekejap and then you will raise your hand and then telling me that this is the wrong question. Okay, all right. So now, new share. Okay, so we continue with the slide before. So we managed to answer this type of question. All right, so now recap a bit on logarithmic differentiation, where dx to a to the power of b is equals to 0. So this is constant because if you can see here, a to the power of b, there's nothing on x involved, right? And then the second one, dx to the power of n over dx, it is obviously n x to the power of n minus 1. And this is called power rule. All right, dA to the power of x is equals to dx, and the derivative, the differentiation will be a to the power of x ln a. So this is the derivative of an exponential function, right? And dx to the power of x is equals to, just now we already answered the question using implicit differentiation and product rule, and we'll get x to the power of x times 1 plus ln x. So this is called logarithmic differentiation. Okay, all right. So now we have completed the types of differentiation: logarithmic, trigonometric, product rule, quotient rule, implicit differentiation. All right. So now these all the types of differentiation that you learned before are going to be used in the application of differentiation. One of the application of differentiation is rates of change. Okay, so now what is rate of change? Rate of change, if you know, is like the instantaneous rate of change of f with respect to x at x naught is the derivative of f prime x naught is equals to limit h approaching 0 fx naught plus h minus fx naught divided by h, provided that the limit exists. Okay, if you remember again, this equation, I think you have, if you follow my class, I think every class there will this apa ni equation muncul lah, exist, right? You can see it, okay, because this is like the basic equation of a differentiation, okay? But using the rate of change, we can find velocity, we can find apa lagi lepas ni, speed, we can find the acceleration, things like that, okay? So the definition of a velocity is the instantaneous velocity is the derivative of position with respect to time. If a body's position at time t is s is equals to ft, then the body's velocity at time t is vt is equals to ds over dt equals to lim t approaching 0. Sama je macam kat atas, cumanya yang ni diguna h lah because dia apa ni umum. Alright, this one we use t because it's something respect to time, against time. Okay. So S ni kalau kita dalam bahasa Melayu kita sebut sesaran kan. So velocity is pecutan. Betul ke? Saya pun dah tak ingat dalam bahasa Melayu dia macam mana tapi lebih kurang gitulah. So speed is the absolute value of velocity. Alright, so speed is equals to absolute value of Vt is equals to ds over dt. Okay, because obviously speeding means you go fast, okay, you don't go slow, okay. If so macam ni dia perubahan dia tu is always on positive manners lah, okay. So definition for acceleration is the derivative of velocity with respect to time. So if a body position at time t is s is equals to ft, then the body's acceleration at time t is at is equals to dv over dt. Okay, a is acceleration, v is velocity. The velocity is actually the velocity is actually apa ni? The derivative of position with respect to time. Okay, where s is equals to ft, so v is equals to ds over dt. So a is equals to dv over dt, hence is equals to d squared s over dt squared. Okay, umpamanya macam dua kali differentiation of the differentiation of the s. Okay, and then jerk pula. Jerk is derivative of acceleration with respect to time. It means that jt is equals to dA over dt, which is equals to d squared v over dt squared, which is equals to d cube s over dt cube. Okay, dia cuma apa ni tambah-tambah lah dia punya differentiation. If you could remember, if I'm not mistaken, on our first derivation class in slide derivative 1, I already show you the ni kan, derivative yang banyak-banyak. I mean after d over dt, then d squared over dt squared, then d cube over dt cube. Okay, dan soalan tu pun soalan-soalan contoh pun ada saya tunjukkan so that sebenarnya I want to show you that it's actually easy for you to solve if you understand the step of solving differentiation. Okay, so now example, determine all the points where the following function is not changing. Okay, gx is equals to 5 minus cx minus 10 cos 2x. Okay, and another one, determine all the points where the following function is not changing. Okay, to answer this type of question, first you have to know that, okay, the question asks you, okay, what is the question asks you to do actually? Okay, here if you find this type of question, the following function is not changing. It means that they want you to complete the differentiation of the function. If in this case, they want you to find g prime x, kan? And at the same time, the following function is not changing, which means at that time, okay, what? The rate of change is 0, okay, which means gx is equals to 0. So in this case, you differentiate it, you will get minus 6s plus 20 sine 2x, okay? So differentiate this to this, you macam congak je lah, kan? Sebab dah familiar with the function, okay? So now, because we want to find where it's not changing, which is obviously it is equals to 0. So now minus 6x plus 20 sine 2x is actually equals to 0. So in this case, when you jawab ni, you solve this, you will get 6 over 20 is equals to 0.3. Okay, so now you can, okay, 2x is equals to 0. Ni you will use your ni lah, apa ni, calculator. Okay, ni saya dah jawab siap-siap menggunakan calculator saya. So x you will get 0.1524 plus pi and or x is equals to 1.415 plus n, where n is equals to 0 plus 1 plus minus 2 and so on and so forth. Okay, so that's the answer. So dia macam soalan dia, okay, apa point yang following function is not changing? So you selesaikan, find the differentiation of the function, lepas tu dekat situ is equals to 0, and then you find the x, so that is the point where the function is not changing. So in this case, the point is 1.4185 plus pi n, which is n is equals to 0, plus minus 1, plus minus 2, and so on and so forth. Okay, so in this case, because the function involve cosine, and then you differentiate it, it will be sine. So nampak macam a bit complicated lah, but that's not that complicated. You can always solve this using your calculator. Okay, student?
Okay, doktor.
Okay.
Doktor.
So, ada apa soalan?
Yes, yang differentiate 6x tu kan, kan dapat negatif 6 kan, bukan negatif 6x kan?
Okay, saya salah. Betul. Kat sini negatif 6. So, salah. Ni pun saya tak masukkan pun kan. Salah. Okay. Try lah kejap lagi lah. Tunggu dah habis saya tunjuk ni, nanti awak try pinjam telefon orang lain ke. Okay. Alright. Okay, tadi yang ni kita tengok determine all the points where the following function is not changing kan. So we dah tengok dah the example 3. So now moving on the example 4. The example 4 ni saya akan buka whiteboard sebab dia panjang sikit. Alright, so now example dia AT is equals to 27, T kuasa 5 minus 45, T to the power of 4 minus 130, T to the power of 3 plus 150. So A prime T is equals to, okay, apa benda saya tulis ni, faham je lah ni. Okay, A prime T is equals to 135 T to the power of 4 minus 180 T to the power of 3 minus 390 T to the power of 2. So equals to 15 T kuasa 2, 9 T kuasa 2 minus 12 T minus 26. Okay, so the point where the function is not changing is at Fn ni equals to function tau student. Saya tulis pendek. T is equals to 0. So in this case, 15 T squared, 9 T squared, okay. Minus 12 T minus 26 is equals to 0. So 9T squared minus 12T minus 26 is equals to 0. Buat, you will get T is equals to 12 plus minus 30 over 3 yang akan dapat negative 1.159 dan 2.4. Guna calculator lah awak kena dapat jawapan ni macam ni. Use your calculator to get this answer. Okay. So, tapi jangan lupa another T is also equals to 0 lah. Okay, sebab kat sini ni T is equals to 0 juga. Okay. So, the function is not changing. Okay. At T is equals to 0. Negative 1.159. Tidak keluar. 1.159 and 2.4. Okay. Okay. So in this case also, okay, I want to show you the function is not changing at that ni lah, okay, at that point. But then if you want to know whether it is changing to whether the function is moving, increasing, for example, sebab ni diguna T kan, kita boleh anggap dia with respect to time, okay, whether it is increasing or decreasing. So macam mana kita nak tahu? Macam mana kita nak tahu the function there after dia is not changing at 0, at negative 1.159 and also at 2.494 kan? Kalau you tengok dekat dalam graph, it's actually like this lah, 0, negative 1.159 and also here, for example lah macam ni kan. So here is not changing, here is not changing, here is not changing. But obviously here and here is changing. So how will you know it's actually increasing ataupun naik or decreasing ataupun turun? Macam mana you nak tahu? Okay, you can know that. You are able to know that the function whether it is increasing and decreasing. So how to do that is put the value on the derivative. Okay, if it is positive, it is increasing. If it is negative, it is decreasing. Okay, so let's find out where is the function increasing and also where the function is decreasing. Okay, so now I'll put like timeline lah lebih kurang So this is like 0, this is 1, so this is 2, this is 3. Okay, so this is like negative 1, negative 2 and negative 3. So here is about negative 1.159 tadi kan. Okay. And here is 2.4. Okay, 2.492. So here is 0. Okay. So you take any any value lah. For example, here you take A prime negative 2. Okay, sebab dia dah negative 2 lah, mudah lah, jangan ambil nombor perpuluhan. So take like nombor yang macam ni and you put it inside the persamaan tadi, which is A prime T is equals to 15T squared, 9T squared, plus minus 12T, plus minus 26. Okay, you put negative 2 here Okay, negative 2 here. So you will get here equals to berapa. Okay, calculate that, you will get 2040. Okay, so you can say that this function is actually dia besar pada kosong. Maksudnya dia ni lah increasing. Okay, so here in that area, so you put like from here to here, ambil satu value, take one value. For example, you take negative 1, which is equals to a prime negative 1. Student jangan ngantuk, bear with me. If you have any question, ask me. You get, maksudnya you masukkan negative 1 here, you put negative 1 here, then you'll get negative 75. And here, okay, you can see the function is actually kurang daripada kosong. Function, okay, ini timeline untuk X sahaja. Or T lah in this case. T lah in this case. Okay. So from here to here, take any value. For example, if you want to take 1, you can take 1. So you masuk sini 1, you masuk T is equals to 1, and you get A prime 1 is equals to negative 435, which is actually decreasing. Okay, kenapa lambat masuk ni? Ya Allah. Okay, which is actually decreasing. Okay, and you put any value here, 3 probably, and you'll get A prime 3 is equals to okay. Wait, where's my whiteboard? Mana whiteboard saya? Oh, okay. Okay. A prime 3 is equals to 2565 with actually you'll get is actually okay. So from here you can see, okay, if you put any value at here at this region, you'll get the apa ni? The function is increasing. Whereas if you put any value from 0 to negative 1.159, the function is actually decreasing. And then if you put from 0 to 2.492, the function is actually decreasing. And if you put any value after the 2.492, after the the point is not changing, you get the increasing value. So here, okay, you can say that. So from here, the function is actually increasing at negative infinity t to the negative 1.159, and also where to from 2.492 ataupun t is greater than 2.492 pun sama juga. Okay, you can write t is greater than 24, okay, ataupun 2.492, okay, sama je. Alright, this one is where the function increasing lah. So where is the function decreasing? Is at negative 1.159 t okay, T 2.492. Okay, fahamkan ni saya tulis ni? Maksudnya tak cukup dah whiteboard ni, dah lebih-lebih dah. Right? So the point is decreasing at this region. Okay, and the point is increasing at this region. Okay, so faham tak? Ada apa-apa soalan ni? Is there any question from here that you don't understand? I can like probably pick up the question that you don't understand. Okay, semua okay ke ni? Tak ada jawapan ke? Semua dah tidur dah? Boleh tak student? Oh student, hello, knock.
Boleh, Doktor.
Okay, faham kan?
Boleh, Doktor.
Sebenarnya dia sangat simple tapi dia macam remeh dan cerewet. But if the function is like the example, kan, tak ada pun menggunakan logaritma ke, Sine, cos, trigonometric kan. Senang je kan sebenarnya kan, cumanya dia agak cerewet. This is the type of question that I love to ask student because I want student to understand how to do differentiation and dia punya application. Okay, this is the application of differentiation. Okay, if you understand how to find whether the function is increasing or decreasing, then you manage to answer any type of this question. Okay. Sambung balik tadi. Alright. So kita dah selesaikan example 3 and example 4. Alhamdulillah. So now we move on to critical points. Okay, what is critical points? This is also application for differentiation. Okay, the definition is an interior point of the domain of a function f where f prime is 0 or undefined is a critical point of f. Okay, so x is equals to c is a critical point of the function fx if fc exists and if either of the following are true. Hal jadi gini. Okay, alright. Saya tak tahu kenapa pula jadi macam ni. Oh, okay, one. Okay. Right. So critical point ni is actually sama macam rate of change, tapi lain sedikit because it can be where f prime is 0 or undefined. Okay, undefined boleh jadi, maksudnya f prime c doesn't exist. Okay, so student, okay, boleh tak saya minta, can I ask you to take few minutes, for example 10 to 15 minutes to complete the critical points. Okay, so as usual, I ask you to have a piece of paper beside you and also a pen or pencil so that you can calculate this. Alright, I also have everything here. Okay, so please take some 15 minutes, 10 minutes. I give you 10 minutes and then I'll ask you how are you going to, how is your ni lah, boleh jawab ke tidak, and then I'll see lah to add more minutes for you or not. Okay, boleh student? Boleh tak student?
Boleh dok.
Yeah, thank
Boleh,
you.
Doktor.
Right. Buat soalan ni, answer this type of question, nanti saya akan panggil you all lah untuk jawab dekat whiteboard tu. So be prepared lah student. Nanti kalau boleh panggil, you can use your mouse lah. Kalau you ada pen, you guna pen. Kalau you ada mouse, you guna mouse je slow-slow lah. Ataupun can you take picture and share? I think you can, right? I think you can. You can share, you can take picture of your answers and then you can share, click share and click the files or whatever screen that you want to share with us. You share your screen yang ada answers tu lah. Okay? Alright. So ingat student, how to do this, how to jawab soalan begini adalah you find the prime or you find the D function here first. When you get the answer equals to something, when you get the answer, this thing must equals to 0. Ada yang critical points there exist, there's a function that the critical point exists, ada yang critical points there does not exist. Okay student, I leave you for 15